base language model works and how when you pre-trained a language model, what what else is required to bring it to a high quality with few examples and what is the important role for supervised fine tuning. Then we'll come across what are the ways we can achieve a high quality response from a language model. And then we'll also see what else other concepts are involved apart from supervised fine tuning so that we'll come to know which concepts plays a vital role in language models response and when to use each concept. So supervised fine tuning. So basically, you must have heard a term SFT most of the times when probably when you are exploring any courses or especially when it comes to YouTube. So you must be seeing this SFT. So SFT is nothing but a supervised fine tuning, which is a primarily important concept where a pre-trained base language model and when it got trained further to bring it to a high quality with some user instructions and there is some idea for to assist your response. So that is the primary importance of a supervised fine tuning. Okay. So the goal here is to how the model behaves and how it is helpful for your assistance based on your user instructions. So supervised fine tuning is primarily very important and almost all the underneath concepts or underlying concepts are involved and helpful for supervised fine tuning. To be honest, if there is no supervised fine tuning, then user will not get a proper response from a language model. So that's a primary and important role where supervised fine tuning is playing underneath any language model. So let's come with a simple explanation. So you have a base LLM model. Okay. So let me draw a flow chart with simple understanding of XFT. So let's come step by step how we're gonna understand supervised fine tuning. So with simple understanding and simple explanation in a very raw terms, a base LLM model already knows the language because it got trained with a huge amount of textual information. So this got at a very first place, this got trained with huge text information. Okay. So if it is got trained with a huge textual information, then whenever you ask any question to this particular language model, it may know how to answer. Okay. It may know to generate the text. Okay. But it may not know how to answer to your question. Generating text is different from aligning the response as per your instructions. So to make sure the response falling as per your interest or as per your instructions or following the response as per your need. So you need something that is called SFT, and this supervised fine tuning will show how the model with many examples to have a good behavior to your response. So the supervised fine tuning will help the model to understand how to respond to the user question. So that's the important role it plays when it comes to supervised fine tuning. So now we got a basic understanding of what is SFT and what is a how the models are responding right now. Okay. So now what is the problem earlier it used to have and what SFT is solving? So we understood that based on the user instruction, the answer coming from a language model will be in a clean format and it behaves like an assistant. Okay. So you change your prompt or you change your instruction if the user instruction gotten changed, okay, so the ideal response assistance will should change as per user need. Okay? This should change. Now, in a very simple explanation, so we got to understand what is this. Now, the problem it is solving is, so user, the responses should always be state focused as per user need. So SFT will solve by making the model understand and give the demonstration on the data. So it will try to have demonstration on the underneath data that it is getting generated. So there is some synthetic data that it's going to generate and it will fall in place as per user need. So this is what a supervised fine tuning does. So there are so many underneath concepts. There is something called synthetic data generation, and the synthetic data will generate as per the user need, and it itself runs in regression testing, and it itself learns something and then respond to the user. So as per the user request, as per the user instruction. So now why SFT was needed actually? So SFT was needed is only for to follow the instructions coming from the user. If there is no instructions coming from the user, then it is just going to generate a textual information which is not falling in place as per the user need. So then that means you need to align the text, you need to align the response coming from the language model, and for that you required supervised fine tuning where it explains, it transforms, converting the textual information into a JSON and act as a assistance or act as a tutor, which will follow the supervised fine tuning instructions, and it will try to predict the text as per the user request. So there is underneath concept that is still fine. Then now, as per when a prompt comes into the picture, okay, so now user is trying to provide a prompt. Okay. So now this prompt is something like explain tokenization, something like this. Okay. Explain tokenization in simple terms. If I say something like this as a instruction, okay. Now, what actually the synthetic data that supervised fine tuning format going to generate? So now the prompt is something that explain tokenization in a simple terms. Okay. Then the completion would be, so the completion would be tokenization is the process of breaking text into smaller pieces of called tokens. Now the completion of response would be something like this based on my prompt. Okay, in simple terms, this is what I explained. Now this is the actual prompt, and you are getting response as per the prompt. Okay. Now at the same time, if the same thing comes under a chat model, okay. So this is something for you're asking a prompt to a large language model, and it is trying to provide a response in a simple terms in one line. Now, if the same question, if I'm asking to a chat model, okay? So for chat model, how this gonna work? Now, the same thing that you're asking, okay, now when it comes to chat model, you will have different roles, okay? So one, you have three different roles, let's assume. One is user role, and the other one is system role, and there is third role that is assistance role. Okay, you have three roles, and now this chat model should behave as per the role. Okay, now when a message starts with a system role, okay, the content should be as per the system's role behavior. If there is a user asking the same question, then the content should come as per the user behavior. If there is a assistance role, and the response should come as per the assistant's behavior. So now how is this gonna identify based on the rule? Okay. So the supervised fine tuning will have that instructions into the model by generating a synthetic data as per the user required and as per the user instructions. So this is how it is aligning the response to the user as per the instructions. So without supervised fine tuning, you will never get a proper intent response to the user. So this plays a vital role, very, very important role. And without supervised fine tuning, there is no LLM response coming correctly. So apart from this, when it comes to now we understood what is supervised fine tuning end to end. Okay, what actually the concept underlying of supervised fine tuning. So then, what else it can solve and how it is solving um, in today's problem. So before this, let's understand how it got evolved. In last 5 years, from 2020, okay, from 2020, there is something called large pre-trained few shot behavior. Okay, so this few shot behavior in 2020, so you give some set of instructions or you give some set of examples. If something is not falling in the example, then the model will never understand as per the example. So you provide three examples. At that point of time, the model understanding is also the reasoning behind the model is also very, very minimal compared to today in 2026. But as per those parameters or reasoning capacity it has, when you provide some few short behavioral examples, the model may reliable only on those particular examples. You give five examples, okay, then the model will try to understand only based on these five examples. It may not understand the sixth example, which is not provided by you. So it will stick to these five examples only if you are providing. Where when it comes to 2020, the model performance, the model reasoning is something like that. Okay. So it may not understand correctly, but it completely relies on these five examples because these are the instructions provided by the user. So you say with these five examples and it follows only these five examples. So because these are coming from user, it is very strict at that point of time. Now in 2021, there is something called FLAN model. Okay. So FLAN came into the picture. You must have heard this FLAN. Okay. There is a research paper on FLAN. So FLAN model came into the picture where the instruction tuning across any NLP task. Okay. Something called as zero shot generalization started with the FLAN paper. So zero shot is nothing but few shot is something that you're giving some set of examples. Zero shot is nothing but instantly it should come with no examples. It should generalize and provide the response. That means do not stick to these five examples. It's something out of the box. The model should have some capacity to understand and generalize the response as per the user request. So they tried improving it with zero shot. And zero shot, if a model is achieving with zero shot, then the model is performing very good. So they tried doing this and it got successful in 2021. Then in the same year, in 2021, after FLAN model, there is something called multitask prompt training. Okay. There's something called multitask prompt training. So this multitask prompt training is nothing but the, the prompt will have a data set which improves the generalization, which will which is coming, which is out of the box or which is held out of the task. So the prompt itself will have some set of data sets or some set of metadata inside. The prompt itself is having some set of instructions with respect to the data. So the model behavioral will definitely follow those instructions apart from zero shot instructions. So all we are trying to understand here is based on the user request, if the model is not having underneath examples, then it should also provide a good response as per the user request. So then the research started in 2020 with few short behavioral examples. Then they observed that if some example is not provided, then model is unable to respond properly in 2020. Then in 2021, there is something called FLAN came into the picture and they tried with zero shot learning with providing no examples and it was successful. Then there is something called multitask prompt training where they are trying to provide the data sets to improve the generalization which is held out of the task. That means if the prompt itself should take care of providing the response by whatever the model it got trained. So there is no additional examples like few shot or zero shot. So it should understand only by prompt itself. This is what they targeted and it got achieved. Now, at the same time, there is something called LoRa. LoRa is a model. Okay. So LoRa is a technique. What kind of technique LoRa is? It's a parameter efficient fine tuning technique where it reduces trainable parameters. So LoRa is something that you have every model has some weights and you see if the model weights are getting increased, then the computation of the model is getting increased and the memory is getting increased, then the size of the model is getting increased. So they want to understand how can we achieve with a minimal memory and performance of the model should be the same. So they came across a technique called LoRa, low rank adapters, where the model can perform better by reducing the trainable parameters. That means by reducing the weights. So it's nothing but if you have a 32-bit quant size, then you're reducing it to 16-bit, then 8-bit, then 4-bit, something like that. So all you're doing is you're reducing the weights so that the precisions are almost similar, but the weight size and the model size is getting reduced. The performance should be the same. That is what they are trying to achieve using LoRa. So if you see these models, each model is trying to improve progressively by raising a problem, by solving a problem with a better version. If you see in 2020, there is something that there is not getting proper response with examples provided, but your model size is the same. Then they targeted something related to the response with the zero shot and it was achieved. Then they thought that without zero shot, I just wanted to achieve only with the prompt. Then they achieved with only the prompt. Then it came across the weight and size of the model to reduce the model so that they can train with a more number of billion parameters with the same compute engine. then that's LoRa came into the picture. Now, in 2022, they have targeted something else to achieve better fine-tuning instructions when it comes to supervised fine-tuning. So supervised fine-tuning has become a core part during 2022 because they understood that though it is generating the text which is not falling in place of user request, then they have came across supervised fine tuning and it became a core part in reinforcement learning human feedback. So at this stage, reinforcement learning human feedback is already existing technique where you take a feedback and the model will try to learn the feedback provided by the user. But what if the supervised fine tuning itself will learn from reinforcement learning human feedback? So if it itself considering this feedback and aligning into the pipeline, then something that model will self improve itself is what they thought in 2022 and it got achieved. Now, similarly, they have progressed with synthetic data instructions into the model. When a user provides any instructions or user provides any prompt, then it should generate its own synthetic data and follow the instructions, and it should have its own validation technique and provide a response to the user. So they achieved something with respect to fine tuning in a progressive way. And from 2022 to 2026, there are several other concepts came into the picture and how the model is trying to respond today with a good reasoning is slowly got improved with the different techniques. One among them is preference optimization. You must have heard about this word, preference optimization. So there are several techniques in preference optimization. So from 2022 to 2026, okay, till today, there are several techniques gotten raised with respect to preference optimization. There are proximal preference optimization, there is direct preference optimization. There are few other techniques which comes under preference optimization, which will underlying fall under SFT, supervised fine tuning, where supervised fine tuning depend on reinforcement learning human feedback and then preference optimization will come into the picture. So before preference optimization coming into the picture, so I already discussed the saying that LoRa is a technique where the parameter efficient fine tuning reduces the trainable parameters, right? So then they thought that this should be reduced over the weights, and that's what it is also known as QLoRa, that is quantized LoRa, where you are reducing the bit sizes also. And today it is almost 1 bit quantization is also being achieved from 30 to 64 bit to 32, 32 to 16, 16 to 8, 8 to 4, 4 to 2, now 1 bit. Okay. The model performance is the same, but trying to achieve by reducing the weights. So that's where the quantization came into the picture. And this quantization will help to understand better performing the model by preference optimization on top of supervised fine tuning. Today, the concept is very big, but try to understand the underneath concepts so that you'll understand the end-to-end how a language model works, how difference of each model is behaving today. You go to Cloud Code, you go to Gemini, you go to DeepSeek, any model you take, okay? These are the underlying concepts where mixture of expert, these concepts comes into the picture, where we'll understand how the model performs on each parameter, or if it is passing the response from one concept to the another concept, how it is preferring a user intent. So these are the underlying concepts, okay? So we'll talk about preference optimization and we'll understand the flow, what it solves, where it solves, and how it would be helpful for us when it comes to RAG implementation. What is the main area that we need to focus, because we are all using the APIs from different service providers, right? So what API and how to make understand only with the prompt, so that we'll achieve better response by understanding these concepts, at least the flow of these concepts. So in preference optimization, there is something called direct preference optimization, okay, which is known as DPO. So this direct preference optimization, it becomes more simpler for us today, because if it is considering this reinforcement learning human feedback, and reinforcement learning is nothing but a reward based model. So reward based model, something that if it is aligning the user response, if it is falling in place as per the user need, then it gives some reward to the model. If not, it will penalize their model. So reward and penalize is as per the user request, but at the same time, direct preference optimization is trying to give a better results, and we'll understand what is direct preference optimization when it comes to a general reward based model. Okay. So earlier we used to have reward based model, that is nothing but reinforcement learning. But on top of this, there is something called preference optimization came into the picture. And this preference optimization is giving a better results. Now in 2026, today, in our modern production of supervised fine tuning, today, the supervised fine tuning is not alone. Earlier, it is alone, but over the period of time in these 5 years, we the supervised fine tuning is working on top of something called parameter efficient fine tuning. That is nothing but LoRa and QLoRa fine tuning. That is nothing but LoRa and QLoRa. And there is something called preference optimization. That is nothing but there is PPOs, DPOs on top of reinforcement learning feedback, human feedback. And there is something called, when any model is trying to get some human feedback, then it is doing self-evaluation. It is doing self-evaluation and it is monitoring and penalizing itself. So these are the almost all the underlying techniques a supervised fine tuning in 2026 it is having. So this level of extensive evaluation is being done today to do a better reasoning, to give a better output compared to 2020, what we have achieved only with a few short examples. Okay, so hope this is a bit clear. I know that it's a bit confusing at the same time for new who are stepping into this area, but the other question is, do you really want to understand all this? Do you really not required to understand all this if you are working as a developer? Okay, but if your curiosity to understand any language model, how it works, and what can I improve, where can I improve my responses, then you definitely need to understand how it works. So this is what I just wanted to bring up. And now coming on to the another way of understanding what it solves is what we thought of discussing, right? So how it solves and what it solves. So there is something called prompting and prompt engineering is a very famous and buzzword, and most of them got to know that there are few positions related to prompt engineering also. Now this, how you are in relating your supervised fine tuning, how is this response falling in place based on your prompt engineering? So prompt engineering, all you know that you provide some set of instructions as a prompt to the model, or your instructions, if the instructions are unclear, okay, then how is your model going to respond? How your model is going to behave as per your response? So these are the things that you need to understand when it comes to prompt engineering. So prompt engineering will definitely solve the problem of any language model that you've been using till today. Okay. So prompt engineering solves the problem when the model is capable, but if your instructions are unclear, instead of changing the model weights, you have to improve the input by prompt engineering. So, for example, you're providing a bad prompt, okay? And if you're providing a bad prompt, then your model will never understand it, okay? But if your supervised fine tuning means a better instructed model can follow a better output response with your prompt. So make sure your prompt is having all the set of instructions. That's where, if you look at today's agentic mode, it is trying to generate the skills.md file to have a good instructions on your questions asked. And it is also, over the period of time, it is updating the MD files. If you observe the Cloud Code or any agent, if you have worked with Copilot also, based on your prompt, it is trying to generate an MD file to have a better instructions. So these better instructions as per your request. So if you provide a concise instructions prompt, what it has to do, then it would solve with a minimal tokens, and that's where you will also manage your context in the model. So prompt engineering will definitely solve this problem. Now, as I mentioned that there are some role-based responses for chat model, right? So any language model, if you consider, there is something called system prompting. Okay, system prompting will also help you how to behave, when to act and what to act. You need to provide those clarifications while sending the prompt to a language model. So there is something called system prompting. Okay. So this system prompting is something that it behaves based on the user message. The assistant will behave when to act and what to act. So you need to give the instructions in the prompting very correctly so that the system prompt will understand and take over the instructions as per the required need or as per the steps that it has to execute one after the other. So you need to make sure the system prompting is correctly behaving and correctly considering by ignoring the few things if it is not provided correctly, or if it is even though if it is not provided correctly, then it should generate its own instructions where that would help to solve your problem with a single prompt so that your cost is also getting managed there. Now coming on to the very third thing, though till these days, earlier we used to have a few short examples placed in our prompt, but now we are overloaded with the instructions itself. So, but minimizing your instructions, having a better prompt with proper system prompting, and additionally you provide your few short examples in your prompt. For example, example 1 says something and example 2 says something. Then, if you are liking the responses which are falling in both the examples, then try to add those examples very detailedly so that your response is not deviating out of the box. So make sure your prompt is also having a few short examples so that whatever the synthetic data that it is trying to generate with this supervised fine tuning that would solve from this kind of prompting. Now, all we are using an API and we have something called RAG-based model. And this RAG-based model will solve the outdated knowledge base and you ingest the data into your RAG and you'll try to solve based on this retrieval augment generation. Now, you are using an API, you are using an external API, and you have a RAG database where you are ingesting your documents. Now, a user asked a question and you need a better retrieval portion. You have your API, LLM API, and you have your RAG-based model here. Okay. And from RAG, if a user is asking a question, okay, user question, okay. So if a user is asking a question and this has to fetch a proper response or retrieve documents, latest documents from the RAG, and it has to send to LLM. So all you are using an API and you have your context getting generated from RAG based on this prompt. Then what else you can do? What else if you do, the limitation is automatically fixed here. So you still need to solve this, but SFT will solve this behavioral limitation that it has. For example, you're not providing the grounding. Okay. So RAG, whatever the response that you are trying to get from LLM, by taking the information from RAG, you will see that there are some 60% will be hallucinated because if your similarity function is not working proper, which you are sending to LLM. So make sure your re-ranking techniques are better. You have a better retrieval or you have a better sliding window portion to fetch the responses correctly. Okay, that is one of the technique that is which is in our hands before you sending the LLM. But even though if you are sending a better retrieval context to the LLM, but if you are not understanding, if you are not able to get a proper response with a proper intent as per the user intent, then you need to improve your prompt with a better system prompting with a few short examples, because all you are fetching the information from an additional external database and sending it to a huge LLM model which got trained with a huge general billion parameters which is not fitting to your domain. Then improve your prompt with some few short examples and system prompting and prompt engineering with the better instructions. Then definitely you will reduce your hallucination there. And this will solve a hallucination to an extent. So I can't guarantee it to 100%, but it will definitely solve. So at the same time, if you can provide some additional sources with grounding in your prompts with your few short examples, grounding is nothing but your actual original response for your user questions. So then this will help to bring down the hallucination there. So good grounding will give you, with a few short examples, will give you better results. So try achieving this. Now, to an extent of supervised fine tuning, or we understood what are the underlying techniques that are present. But at the same time, when it comes to supervised fine tuning, and there is something called instructions tuning. Okay. All these techniques or buzzwords are important. Making sure understanding in detail how to improve a prompt so that you achieve a good response from the LLM. So instructions tuning is nothing but a general purpose of assistance where you provide some task categories. Okay. So if your task is something related to summarization, then give it correct instructions as per the summarization. Okay. If your task is something related to code generation, then provide something a better instructions related to code generation only. Or questions answering, provide good examples, how we need to respond, what are the roles in the questions and answerings, and you provide a good response, good instructions based on that. And if it is a reasoning or if it is a classification, so whatever it is, whatever the data or whatever the response that you're trying to fetch. So instructions are very important, and make sure your prompt is having a better instructions underlying. Okay. Now, there is something called synthetic data generation. Synthetic instructions data. So now what is synthetic instructions data? So now whatever the instructions that you're trying to generate, if it is a human written instructions, the data is expensive and it will be very slow to create because it is human written instructions which are complicated, and which are complicated in the sense the model should understand the human instructions at a very first place. Okay. Now synthetic instructions data solves by using the model. Okay. The model itself will generate more training examples because model already got trained and it is very easy for a model to generate its own example. But if a human is trying to provide an instructions, and it will take a lot of time to understand those examples, and model may or may not understand completely 100% to generate those examples. So synthetic instructions data is something that model itself will generate the input and output responses, so that model understands better what to generate the answer based on the new instructions coming in. So you're making the model itself to generate its own data instead of you providing additional data, something like few shot or grounding, or if you have some chat model and you have something role-based model, then it is very difficult for model to understand in one-liners what is this role is doing correctly, because the role can have n number of responsibilities, and even if one keyword is getting changed, then the model get deviated with that particular keyword if it has more weightage. So we need to take care. So all I mean to say is, so synthetic instructions data will help the model to better understand or generate better examples on its own than human giving an additional source of examples, and model gets confused. It cannot generate 100% accurate examples how to respond based on the new intent or new user question. So there is something called domain fine tuning. There's something called domain fine tuning. So domain fine tuning, you are making explicitly the model to understand which domain it should consider, which domain it should not consider. So for example, if any LLM, if you take, LLM got trained with huge corpus of data, right? So now it might consist of the information which may belongs to different kind of domain, right? So now you are explicitly mentioning, saying that do not focus on something another domains, or focus on only something related to so and so domain. Or if your external data set has some metadata, then you can narrow down
Yeah. Abhinav? I think mentor is disconnected. Give us like few minutes, okay? Let me reach.
Yes.
Yeah, just came to know that he got internet disconnected and he'll be rejoining. Yeah, please be patient. Meanwhile, Apurup will just like go over our course plan and you know this the GitHub projects. So it helps to the new people who joined today. Like he will go over just like few minutes. Thank you all for retaining. I see like it's going very interesting.
Yeah, thank you all for attending today's session. It's been great sessions so far, and we could see a lot of positive response from all over the people who have attended these trainings. So try to subscribe this KKR Gen Ai YouTube channel to get the recorded sessions. We have uploaded all the recorded sessions of this 30 hours bootcamp in our YouTube channel. Try to subscribe. So I could see a lot of new people have joined. So for them, like, please go to the KKR Gen Ai Innovations and get all the previous batch videos, recordings, and the particular the current recordings have been also uploaded daily. So try to follow the YouTube channel and also try to follow the LinkedIn page to get all the updated information about the upcoming boot camps and also the regarding all the sessions that we are conducting. We'll post everything and keep you updated over the LinkedIn page. So that will be beneficial for you. Like even we post some of the AI jobs. If there are any openings, you'll be getting to know from our YouTube channel. So it will be beneficial for you. It is KKR Gen AI Innovations LLC. So try to follow YouTube and LinkedIn both. And we are starting the new batch from May 16th. So it's a 100 days program, and you'll be getting to know like right from the beginning. We start with the foundations of AI and also with foundations of Python programming and libraries that we use for the particular generative AI topics. So definitely this 100 days program will be beneficial for you to get the hands-on on machine learning, deep learning. Like in the machine learning, we start with supervised, unsupervised learning, and in the neural networks, we teach different topics, and in deep learning, we cover different topics, and then we go on to the NLP. And in the part two, we cover the generative AI from LLM fine tuning and agentic AI frameworks like LangGraph, LangChain, Crew AI, and also like we have designed some of the Google Vertex AI chatbot creations and how you can deploy all these agents into the cloud. Everything will be covered under the 100 days program. So this PDF will be shared to everyone. And also coming to the no code tools, we also have some of the Notion AI, ClickUp AI, and also N8 and Make.com, Zapier. So many no code and low code tools will be covered under this course. And we also teach prompt engineering fundamentals, advanced prompt patterns and techniques like chain of thought, zero shot, few shot prompting. Everything will be covered under this one. So we'll share this PDF to everyone. Try to fill out your details in the registration or enrollment form. We'll try to reach you offline. So it is not a confirmation in the registration form. It's just giving the details. If you are interested, we'll give you all the course content and we'll explain you all the details regarding to the new batch. Then you can make the decision on the next batch, which is starting on May 16th. So, in this course, we also cover like MCP protocols and A2A, and all the will provide you the capstone projects where you can work on and get the hands-on with your particular AI projects if you are coming from the different backgrounds. So for coming to the projects, for the GitHub projects, we have like, for the people who have joined today, for them, like, these projects will be given access to everyone, those who enroll, and also you can start exploring these projects from the level 1 projects. We have 10 projects where you'll be like starting with the beginner level projects to work on, and also this will be beneficial for you, like if you're coming from the different backgrounds with the non-IT or a different technology, then definitely this beginner level projects will help you get the idea about how to start with and how to implement the AI projects from by your own. We'll give you the guidance from our mentors, and also like this will be beneficial for you in the overall aspect. So, and also with the level 2 projects, you'll be giving all the intermediate level projects. You'll be working on the RAG architecture and also vector databases, agentic workflows, automations, and everything with the 10 different domain and industry projects that you'll be working on. So you'll be hands-on with complete LLMs and RAG frameworks, backend frameworks, and also external integrations. So this will be beneficial for you with the level 2 projects. So if you go to one of the projects, you'll be giving complete information about the problem statement, objective, system architecture, and tech stack, and step-by-step implementation guide, so that you'll be giving you'll be getting a lot of exposure to implement these projects. And the last level is the advanced level projects. So you'll be working completely on the full stack AI projects will be given to you, and you'll be implementing them with the different industries. You'll be working with multi-agent orchestration, fine-tuning, real-time streaming, and also with the LangGraph agentic AI framework that will be useful for you in the overall aspect. So you'll be hands-on once you complete these 3 level projects. You will be hands-on with the end-to-end. We'll get complete idea about how to start with and how to deploy them. So with the LLM providers, agentic frameworks, fine-tuning, and also with the databases that you'll be working on and the cloud platforms and the front end, back end, everything will be given with the overall idea to start with. So definitely, try to enroll in the with the given enrollment form in the chat by our team. So we'll reach you offline and help you out with all the queries that you have. Thank you. I think Abhinav have joined. He'll be continuing the class. So yeah, thank you everyone.
Yeah, thank you, Apurv. So, yeah, so let's continue from where we stopped. So till now we understood there are different ways of techniques, and there is something called domain fine tuning, and you explicitly say that on which domain you are working in your instructions. That way your hallucination would solve. So now our basic fundamental focus is how to get a proper response as per the user instructions. So this might solve your hallucination to an extent, and also this will also solve your managing the context before you sending it to LLM. So till now what we have discussed. So the base model will reliably not follow the instructions, but it will try to generate the text. So generating the text will definitely have some hallucination kind of problems. Then you need to make the model understand what exactly the response you're looking for. So in this, what we have covered. So there is no training solution is one of the methodology that we followed. And the other one is database, data-based training. solutions. So we'll list down all the solutions that we have covered till now. Okay. So database the training solutions. And then we came across something that preference alignment, that is nothing but um, preference optimization is what we talked about. So preference alignment. So there are several techniques under preference alignment, and then you at the fourth place you have something called that is production controlled solutions. Okay. Now we'll talk about this preference alignment, and till now whatever we have discussed will fall in this two set of categories. So what all we discussed? One is something related to prompt engineering. Prompt engineering. Then you have something called system prompt. System prompting. Then you give some few examples, and then this will align as per your examples. That is nothing but few short. Okay. And then you have something RAG, and when it comes to RAG, then you have to explicitly provide some grounding, the actual responses as per your need. Then it would solve some hallucination. At the same time, you can externally use some tools, call your MCPs or .md files to provide additional instructions, and that could follow the additional instructions, and which doesn't require any training solution there. So training means you are not externally providing any additional data set. So this is what solves with no additional information. And this could a few shot, not every time few shot is required. For few set of examples which you already knew, then few shot will help, but not every time few shot will help. So based on your use case, you need to align as per the required need of the intent response you're looking for. So that's how you need to solve the problem. Now coming on to database training solutions, what we have looked into. So there is something called supervised fine tuning that we knew. And supervised fine tuning is solving the problem to an extent by generating its own data. Okay. Now there is something called instructions tuning is what we mentioned. Okay. You explicitly provide your instructions and you tune as per the required need. Then additionally, it will take care based on the instructions. Now you have something that is domain based tuning. So you need not to ask model to explicitly go and explore additional domains which are not required as per your need. So if you are specifically looking for so and so domain, then you need to fine tune or provide an additional set of instructions based on your domain. So that way it could solve based on domain. Now, if you are going with the fine tuning model, or if you are trying to train a model as per your required need, then there are two techniques that would be helpful. That is LoRa and QLoRa. If you are using API, this would not help, but if you are trying to develop a model from scratch, then LoRa and QLoRa will definitely help you to utilize better compute while training the model. Then at the end, you have synthetic data generation. And instead of you as a human providing, or a user who is trying, or a developer who is trying to develop the application, instead of uh, we externally providing it. So if we ask model to generate your own synthetic data, and if you validate the synthetic data based on the instructions, then that would be more helpful for us and achieve better results than we explicitly telling and making the model confuse. So synthetic instructions data is very, very plays a very good role when it comes to you providing the solutions or expecting the less hallucinated response from the model by additionally providing all these instructions. Now, the very important one that we are trying to understand, okay, we are not, all the models are right now are having productionally having all this information in it, concepts in it. Now, we are additionally understanding which would help at what time. Okay. So now, preference alignment. So what are the preference alignments we have? The very first one is reinforcement learning human feedback. At a very first stage, we were having reinforcement learning human feedback. And then before reinforcement learning human feedback, there is something called reward model. Old methodology, but you give some credits or you give some rewards plus one or minus one. So these rewards are considered and the model will try to respond as per the requirement. So reward models are something that you give some credit to the response when the model is trying to generate a response, or you penalize the response when it is not falling in place. Then you have something called reinforcement learning human feedback, and human is explicitly providing some feedback based on the response. And if it is aligned as per his need, then he reacts or clicks on a like button or gives some positive feedback. Then the model will try to align as per his request. Then you have something called DPO. DPO, it is nothing but direct preference optimization. Then you also have PPO. PPO is proximal policy optimization. You have PPOs and DPOs. We'll talk about this when we will, what is the problem with PPO and what is the problem with DPO. We'll understand the concept of it. Okay. There are few other concepts, something underlying, which are more related to proximal policy optimization and direct preference optimization. So there are few other concepts, though those are nothing but ORPO, KTO, IPO, and SIMPO. So we will talk about all this. Okay. Then additional, what are all these? There are in details and their problem statements. We'll look into those. And at the same time, finally, I want to give make you to understand there are two ways of, till now we have generated reinforcement learning human feedback. Okay. At the same time, there is a new technique that is nothing but reinforcement learning AI feedback. Okay. So that is nothing but I'm trying to put it all together. A reinforcement learning AI feedback. So something that you already knew, that is LLM as a judge or something. So it will consider how LLM itself is giving a feedback, whether the response is same, whether the response is very safe, whether the response has less verbosity. So few things, whatever the instructions that you provide in the AI feedback, it will try to look into those feedback and it itself try to improve the response as per the user request. And if the AI feedback is pretty much aligning to the user, then you are good to go. Then at the end, the production controls are nothing but you have your guardrails, your output validation, and your safety filters, removing the PA information and taking the human reviews. So all this comes under the regular general production what we are taking care. But now let's focus on reward models, reinforcement learning, and PPOs and DPOs. Let's understand all these concepts. What are the problem statement and what it solves? So let's come to PPO. So PPO is nothing but proximal policy optimization. Proximal policy optimization stands for what it stands for and what it is. Okay. So it's a reinforcement learning algorithm which is used in reinforcement learning human feedback pipelines. Okay. So PPO updates the model so that PPO it itself updates the model so that it gets higher reward scores. Okay. While preventing the model from changing too aggressively. For example, if a model response is trying to change very immediately from one prompt to the another prompt, that means whatever you have achieved in a prompt A, you have some score. Let us think you have achieved 60%. Okay. And if prompt B, whatever you're trying to achieve is somewhere around 100%, you're achieving 100%. And then in prompt C, if you are achieving 10%, then the model is trying to change very aggressively around 50 to 40% every time. Then the aggressiveness, whatever you are seeing, okay, that is nothing but the instructions provided to the LLM is not so correct. Maybe anything could be the reason, okay, but the proximal policy optimization will understand this better to align the stability by optimizing itself. So that is the trick, or that is a concept that is present in proximal policy optimization, which will which became an important in LLM alignment. Okay. And this is a purely reward based model. This will try to self heal the human feedbacks, and this is pretty much aligned with the pipeline of human feedback loop. So that is what a proximal policy optimization. So the key idea is the original model, the response should not move, or the response should not deviate very aggressively. Instead, it should align the user intent and change or divert correctly as per the required need of the user. So it will not, it will give a better rewards and better scores to the model so that the model will try to align correctly. So this is what proximal policy optimization does. And after this class, you can explore more better on what is proximal policy optimization and how it works and how it is aligned. Now let's understand the another concept, that is nothing but DPO. So DPO is nothing but direct preference optimization. So this direct preference optimization is nothing but you have chosen a response or you have rejected a response. So the model will try to train separately based on which you are choosing and what you are not choosing. For example, in DPO, you have two set of responses that model will try to align. Okay. So one is you are rejecting. Okay. Your response is rejected. One is you have chosen. Okay. You have chosen a response. Now, these are the two things that DPO considers. Okay. Now, if you are preferring something, if you are choosing something, then this will consider and train only the preferences that you have chosen. Okay. If you are not choosing that particular response, then if you are rejecting that response, if you are not considering that response, this direct preference optimization will never consider those response. It will only consider the response which you have chosen and align as per the request. So this direct preference optimization is pretty much aligned with proximal policy optimization because this is changing very aggressively. And if you want to align as per the user intent or user request, this underlying direct preference optimization will train on the preferences chosen by the user. Okay. So this is another flow. coming from PPO, and then which are almost underlying concepts of reinforcement learning human feedback. And this reinforcement learning human feedback is purely depending on the reward based model. And then you have DPOs, and then you have PPOs, and the PPOs should not aggressively change. For that, you need DPO, which response the user is trying to choose. The model will try to understand on those preferred responses only. Now, on very third thing is, so DPO is simpler when it comes to PPO. PPO is little bit complex because it has to understand each prompt, and it has to pretty much align very immediately in the pipeline of human feedback. But DPO, it is very clear. Either you choose or reject. Then it will ignore the reject portion and it will choose only the chosen portion of the response. Okay. But though it is very simpler, this DPO is still heavily depending on the clean preferences of the responses coming from the user. Okay. Now you're choosing prompt A and it is 60% aligned. Prompt B is 100% aligned. Prompt C is 10% aligned. But user might choose prompt A instead of going with prompt B because though it is 100% accurate. So your alignment is only 60%. Then the DPO should understand the pair of responses where user is trying to look into. So it is pretty much difficult to choose those preferences of cleaned pair references and to train as per the required. Or it is also very difficult to the DPO to understand which portion of the responses he is trying to reject. So both are very difficult, right? So though it is looking very simpler, but practically it is very difficult. Now, there are something called ORDPO. Okay. ORPO. Okay. ORPO, KTO, and IPO and SM. So these are different set of instructions where ORPO stands for. Okay. So ORPO stands for odd ratio preference optimization. That means supervised fine tuning and preference optimization both coming together onto one training objective. That means if it is training, the model is getting or learning from something gotten chosen, something gotten rejected. So both the techniques, supervised fine tuning and proximal policy optimization technique, both coming together and then providing the responses by filtering the odd ratios from the user response. So that is something that which would solve the underlying DPO's problem, because DPO is bit confused which to choose, which to reject. Then OR DPO comes into the picture to provide the ratio of the responses which are odd, which are correct, and then the model choose the right response based on the OR DPO. OR DPO, I'll write a full form here. It's nothing but odd, something but odds ratio preference optimization. Odds ratio preference optimization. So this will what problems this solves? This is helpful to DPO to provide a good reference pairs to choose what, so that it is aligned correctly based on the reference model. And this is pretty much aligning with the signals coming for the supervised fine tuning, and it is also helpful for PPO, all the hierarchy concepts, DPO, PPO, and then reinforcement learning, and then supervised fine tuning. This odd ratio preference optimization will filter something like odd man out. Then the direct preference optimization will go and choose wisely which pairs are correct. Then it will try to provide the response to the user as required. So That's the main intent of odd ratio preference optimization. Then, what is the main weakness of odd ratio preference optimization? The main weakness, or it can be sensitive to prefer the data quality, or it could be sensitive to the loss. What it could be sensitive? It could be sensitive to the loss balancing. It is very difficult for this odd ratio preference optimization to balance the sensitivity between the ratio of choosing, the ratio of rejecting. So it has that sensitive, very sensitive to that area. If it is providing highest weightage to chosen, the pairs of chosen, then the direct preference optimization will choose those pairs of chosen only. Then whatever the information coming from ORPO is totally wrong, then user will never like the response. So it is very sensitive and it is very weak to the balancing the loss. Now let's come to the IPO. What is IPO? IPO is nothing but it is identity preference optimization, which means the identity preference optimization will prefer optimized literatures only. That means it will additionally introduce theoretically how the DPO is trying to prefer the learning, especially not to overfit when it is more deterministic. For example, all the language models are non-deterministic, correct? If if all the language models are non-deterministic, if the responses coming from the user or if the responses liked by the user are more deterministic, because there could be some responses which could be very pretty straight, then IPO will try to make the DPO understand that you are not so overfitting the responses. You are trying to normalize the response and it will try to tell the learning objective to the DPO by identifying the learning objectives in the DPO style. All it will take care is not to overfit the response. Okay, not to overfit the response when direct preference optimization is trying to learn something. So now what is the weak area for this IPO? IPO, to identify the preference optimization, it is more theoretical and it has less commonly been used. Okay, it is less commonly being used and it is more into theoretical concept. Then the DPO will still prefer the pairs which might be overfitting, which might be interlinking with the odd ratio preference optimizations also. So all these concepts are interlinked to each other and very sensitive to come to a conclusion. Okay. So there is something called CPO. Okay. CPO is a technique. CPO is a technique where it will try to contrastive the preference optimization in the context. So this CPO will train the model by contrasting the preferred and dispreferred outputs. So you see, one is trying to give a conclusion. If PPO is giving a conclusion, then DPO is trying to validate the PPO. If DPO is giving the conclusion, then ORPO is trying to validate the DPO. If ORPO is giving some conclusion, then IPO is trying to make sure that ORPO is not overfitting the responses. If IPO is trying to provide some conclusion or trying to make sure the model is aligning, then you have something that is contrastive preference optimization, which is trying to prefer and which is trying to segregate preferred outputs and dispreferred outputs to make the machine translate the work into a helping model to avoid the outputs which are accepted, which are not ideal also at the same time. So making sure that the model is non-deterministic, at the same time, model is not sensitive to the area where it has to focus. So very wisely internally. All the experts are working very properly from from one concept to the another concept, making sure those are not sensitively responding to the user intent. Those are very wisely trying to control the model, trying to put in place when user is trying to look into the response. So with this, I just wanted to conclude today's lecture. And if you have any questions, please let me know. We can take those questions. Any
Ram garu,
questions?
can you unmute yourself?
Can you unmute yourself? Thank you, sir. Hi, Abhinav. Thank you for that explanation. So, like you said, if I am a developer, I'm not interested in detailed information of all this, and I want to use optimization. What is the best way to use, and which is the best model to use?
So model, you can go with any model. That's not a problem here. But prompting is only the best way to control your model.
Okay, if that is the case, which is the best prompt optimization technique you prefer or you suggest if I don't have any knowledge about all this?
Yeah. So, for example, you write a regression, the technique that I follow exactly. Okay. So write a regression test. How is your LLM trying to respond from each question or each, if it is a chat model or whatever the model that you are trying to use. So try to write a regression test and give some confidence scores. And if it is not falling in place, then try to improve your prompt in which areas it is very less. So for example, let me share my screen.
One question in between, sorry to interrupt. So when you say confidence score, do we give the confidence score or we ask the LLM to give the score?
LLM to give the confidence score, and you need, as a human, you give your response correctly. For example, now let me take a table. You are writing a regression test. Okay, write a regression test. Same prompt, prompt A. So this regression test will use the same if your prompts are static, okay, every time the prompt will be the same. But the context that you are retrieving from RAG or the context that you are providing additionally along with the prompt will add. Okay. Now in this regression test, you're trying to hit LLM. This is your LLM API. And from LLM API, you get some response. Okay. And try to generate a confidence score. Now this confidence score is somewhere around 60%. Okay. So
Which
similarly,
manual?
you write a regression
Sorry.
test for all, uh, for at least a few examples, you write a regression test. Similarly, you're doing a regression test for all. Okay. Now in this 10, you somewhere see 80%, and then you see 20% for few responses, because your context is getting changed here. Your prompt is same, but your context is being changed. This is context A. This is context B, C, and D. Now, in all these contexts, the dynamic is only context and the response is very dynamic, and that's where your scores are very different. Now, try to understand why did you achieve 80%. Okay. Now, based on this observation, if you are pretty much liking if it is giving 80%, then you understand why it is giving 80%. Then you have some feedback. Okay. Now, if you're liking this and you say this, you're agree with this. Okay. Then now understand how to achieve a good context to achieve a good score. Then based on this, improve your prompt. That way you will try to improve your confidence score. That way you will at least achieve for all the responses a good score.
That makes sense. Thank you so much. And one
Yeah.
more question. So if we are
Uh-huh.
using LLM as a judge, can we attain the
Mhm.
same thing, or do we have to do something
Yeah.
else?
So this confidence score is getting generated with LLM as a judge.
Okay.
So
Okay.
it in one call you're getting response, and the next call you're asking validate the response, and you generate a score for the validation. And if you're saying 60%, then you can also explicitly write, okay, reason for score. Then it will give some reason. Now you consider those reasons. It says some XYZ, something, something it says. Okay, then you read the response, read the reason for that, and then try to improve the prompt or improve the context in your retrieval portion. And then you can, that way you will solve your problem.
It is very simple and very perfect explanation. This makes
Yeah,
sense.
yeah,
Thank you.
yeah. You're welcome.
Yeah. So please raise your queries if you have any from this class, or you can also ask us about the new batch if you are looking for to enroll. Yeah, we just send out that new batch form. If you fill using this form, you'll be now giving a special discount. That's what I'm doing. And just say that you fill the enrollment form and you're looking for a discount when you talk with us. That helps us. So because by filling this new enrollment form, you're saving a time. So please, if you're seriously looking for training, deep 100 days plan training and association with us. So once you enroll, you will be allowed to, give access to GitHub, our training links, our recording links, unlimited days, and you can also join as many as batches until you're comfortable. So one time fee, you can join as many as batches, unlimited access to our recordings and our knowledge resources. So I request everyone to get your one-to-one discussion done. And if you're comfortable, you can join our regular batch, which starts from May 16th. Okay, Anil Garu, please unmute yourself. Anil
Hello,
Garu, please go ahead. Yeah.
can you hear me? Can you hear
Yes,
me?
yes, Anil. Hi. Yeah.
Hi, Abhinav. Good morning for this wonderful detailed presentation. Quick question.
Thank you. Thank you.
So I see you've given the complete history or evolution of these LLMs since 2020,
Mhm.
and what are the things
Mhm.
that the LLM authors have done to improve it, right? So
Mhm.
today, if so, these are the steps that they do. Like if somebody creates an LLM, that they just take
Mhm.
a and which has no SFT. So there's just a pure
Uh-huh.
base. Then they do the SFT and then the DPO, and then
Yeah.
okay,
Yeah, they do
all
all this. Yeah, correct.
okay. All right, thanks.
Yeah.
I'll ask another question later, but yeah.
Yeah.
Thank you, Anil and Abhinav. Yeah, please raise your queries if you have any. Yeah, if you do not have any questions, I think you are allowed to exit. Please encourage our mentors LinkedIn also. Please follow, and it's kind of encouraging them. Please follow and connect with them if you have any queries as well. We're allowed to do that, and yeah. So someone talking, please. Yeah, if there are no questions, you are good to exit. Thank you all for joining. So we'll be notifying if there are any other no free classes from next week onwards. So I see people doesn't have any questions. So thank you all for joining today class. Thank you, Abhinav. Thank you so much. Uh, yeah.
Thank you.
Abhinav, you can drop off if you want. The people who have any
Sorry.
general questions, they can.
Yeah, Abhinav, can I hold you for another minute?
Yeah,
Because
please,
I
Yeah,
thought
yeah,
please.
definitely.
I thought people will have a lot of questions. Because it's a little more complicated and a very
Yeah,
sophisticated subject.
correct, correct. So
Uh,
today's concept is bit heavy concept actually.
yeah,
So that's
yeah.
fine. I understand. Yeah.
So first of all, thank you so much for making it so simple and making it y- at least know the concepts and details. Um,
Mm-hmm.
so, like I said, if it is so complex and if we don't use it on a daily basis, do we really
Mm-hmm.
need to know all this to use or build LLM
So
applications? Or, yeah, go ahead, please.
no, no, not required. Not required. My intention of explaining in detail is because one thing we'll understand how LLM internally works. If you understand how it works internally, then explicitly you can provide few information which it should consider, which it should not consider. That is one where you focus on your prompting or you provide some additional instructions, right? That's how the skill.md files getting generated with the agents. So now every time you prompt your agent is improving. Okay, you're doing some additional work. You get deviate also. You get sometimes you get deviated your track what you want to achieve. So these are the underlying things that if we understand, then we'll focus on which area we need to focus. Now, going forward, in our olden days, I've been repeating this in my previous classes also. So going forward, I strongly believe that tomorrow you will just import an LLM model. You will how you are importing ML models now or DL models now or any libraries. Tomorrow, my strong belief, you will definitely import a LLM model. So if you are importing the LLM models, then you need to know underlying techniques, how it works from today. Because in a over a period of 5 year span, if you are seeing this much of improvement in the research area, then today we have seen, I have recently seen a podcast from NVIDIA also that every house is going to be a standalone GPU box setups in every house. So you see how much of way it is trying to improve in a day to day. So my strong belief tomorrow, within a year, you will see some additional set of topics or new concepts getting generated and these become very old. Then if we do not understand these concepts, then it will be too big for us to understand those concepts which are coming from these areas. So I just wanted to keep that track for everyone so that at least we are not forgetting the concepts.
Yeah, that makes sense. And so you mean to say, so these will be there, these concepts will be there. On top of it, we'll get it get updated or refined, or there'll be more concepts on
Mhm.
top of it in the future.
Yeah, yeah,
And
definitely. Definitely.
okay, okay. So and you're saying that in the future we might every household or every company will have their own models downloaded, like Olama 3, something like that, and trained
Yeah, possibly.
based on okay, okay. So
Yeah.
so
We
people
never
need to
know.
know.
I can. Uh-huh.
So in the future, maybe in the near future also, if companies need to
Mm-hmm.
know how to download a model
Mm-hmm.
or a free model or base model and train
Mm-hmm.
their data on top of it and use that model.
Yeah,
Am I right?
use the model. Yes, correct.
Okay. 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 That's a great
See,
information. Thank
today
you.
we got
Then it's better to
MCPs, right?
learn. Yeah.
Yeah, yeah,
Yeah.
yeah, that's what my intention is that it is always good to learn and keep a track of all the concepts. So the fundamental concept of overfitting is still existing in every language model, if you observe. Okay, there is nothing beyond the topic that we are not going ahead. So you see, every response is getting validated, and every time it is trying to think not to overfit. It is trying to balance the loss at the same time. If you see, the underlying concepts are same, but the way it is performing is different. The
Abhinav,
name or terminology is different, but underlying is same again.
so
So,
what does overfit mean here? Like, since you brought that up, so
so
does it mean that the
overfit
model
is like,
memorizes specific examples and uses that in answering any
yeah.
other question? And is that I'm probably at a very high level. This is what I'm thinking. Is overfitting? Does it mean that?
Yes, yes, that is what overfitting. Always you give any question, you ask in any different way, but model is trying to provide the same response.
Because I heard that you said, sorry, Ramu Garu, I intercepted while you are
No, no,
asking
you're good.
question.
You're good. No, no.
uh,
Thanks for sharing.
Please, I think this is like a conversational style. Since he has few more minutes, maybe we can all discuss and to get better grasp of the concepts. Because you said
Yeah,
uh,
I was just taking advantage because nobody has questions. That's all.
same here.
Yeah,
In
go
fact,
ahead.
that's why. And so, because this is very detailed, he has given a complete evolution of like how the original models were a few years back and how they have evolved. What were the cons or limitations of the earlier model, and how the next one has improved it. And that was a clear timeline. Because this is so much of a wealth of info, somebody who is not from a AI or ML or DL background, suddenly if you come in, this is overwhelming info, and just to to fit your brain around this from like 2020 to 2025, how it evolved, probably at a high level for each model, for each evolution, if there was a simple example analogy and how that would have probably explained in our brains much better, I guess. But coming back, you said DPO can overfit, and yeah, DPO is like you said, right? I think the IPO
Yeah.
fixes that, right? So
Hmm.
how does it? How does IPO fix that? Uh,
Yeah. So, in depth, I did not consider here because all I want to introduce the concepts
okay,
only.
sure, sure, sure.
So, yeah. So, overfitting, there is something KL diverging, if you heard about. Is a graph where it will try to diverge, okay,
Okay,
diverge and converge. So that is something related to overfitting and underfitting concept, okay. So underfitting, you do not have proper data, how to generalize. Overfitting, you have a set of data for all the set of questions, and you overfit the model so that you give the same response though you are asking a different question.
okay,
Okay, so that's how the model behaves. Now, DPO is something that is either choosing yes or no. Then you have some set of ratios which user is preferring, which user is not preferring. The model should follow very immediately or understand very immediately based on the ratio. Now, now, if you observe one concept to the another concept, PPO is something aligned with reinforcement pipeline, human feedback pipeline based on reward model. Then DPO is coming. Then DPO is aligning with PPO. Then you have some ORPO ratio, and the ratios are pretty much providing the weightages between the two set of distributions. One is choosing and rejecting, and then you have IPO where the KL diverging is coming, graph is coming into the picture, and it was trying to uh, look at the portion or sensitive areas, not to be more deterministic in providing the response. That's where CPO is coming into the picture. You see, for one concept, the other concept is
yeah.
validating.
Mhm.
So yeah, but I could come with a good set of examples and provide a good set of discussion also. But earlier I thought in one of the class I was trying to explain in a depth way with a mixture of experts from the tokenization and transformers architecture. But it was, I did not see that proper interaction. Then I felt that okay, it might be too much heavily loaded So I did not take that consideration. So that's why
Yeah,
now
no
I
worry.
put very high level, at a very high level. Yeah.
Yeah, which is good actually. And also, like
Yeah.
during the interviews, like do they
Mhm.
like touch base upon these earlier versions and ask the potential candidate like what are the pros and cons? Like,
Mhm.
do they ask like that? Like the
No, no,
LLM architectures?
no, not at all.
Okay,
No, unless you go target some big companies
I
who
see.
has their
Okay,
own models.
okay,
Yeah. So even now, even I was also focusing on that areas. And the concepts are very, very big, very huge. Yeah.
okay, okay.
So
Thank
it
you.
is like
Can
Damodaran,
that.
we
please.
can we have a couple more minutes? Do you have a couple of minutes?
Yeah, yeah.
I have one more
Go ahead.
question.
Yeah, go ahead, go ahead. Yeah, we have like 5-10 minutes more. Yeah.
Okay, okay. Can you like Anil asked, can you brief some topic or something on the interviews? Like how are they focusing? What are they focusing on? Any sample topics,
Yeah.
questions? What they exactly look
Uh,
for?
I can provide you the list of concepts. Not in question level, detail level, I cannot,
Yeah,
but
yeah.
at a very high level,
Mm.
because the areas I am focusing, I can share those things with you. So the very first one is how transformers works. That's a very root area that you need to focus. You need to understand that. Without a transformers question, there won't be any interviews when you are looking for a position for LLMs, like related
Oh,
to
okay.
Gen AI. Okay.
Okay.
And these are the areas, these are those companies if you are targeting, where they have their own LLM models. Okay. If they are dependent on service providers, then the interview questions would be different, and the areas that you need to focus is different. How can you build a RAG pipeline? Those are the areas that you need to focus for enterprises, not for service providers. If you're targeting for companies like Anthropic or something who has their own LLMs, then the interview questions would be so different. Okay, so
Yeah,
now
yeah. Thank you.
I'm going to tell those concepts in depth. One is transformers that you need to focus, and the other one is how self attention works with KV cache and so KV cache is key value pair. Okay, so you need to understand
Mhm.
how this KV cache is working. Okay, then there is something called autograd and graph based techniques. So, which comes under gradient sanity checks. So, there are few concepts that you need to take care. Maybe it is, I don't know whether it is very new terminologies, but this is one of the area that you need to focus. Okay. Now,
Okay.
coming on to uh, as I discussed about supervised fine tuning, you need to understand
Mhm.
how the preference optimization works when it comes to supervised fine tuning. Okay. Then the other one is called distributed system. How the distributed system works. How are you trying to identify the bottlenecks in when you are trying to train a model, especially on GPUs? So that's one area that you need to focus. And especially reinforcement learning is very, very important. How reinforcement learning, human feedback works, and how you preference the data sets, how you create the synthetic data set based on a user query, how DPO works, and there is something called a regularization techniques that you need to focus. When you are trying to preference the when you're trying to not to overfit, because LLMs are non-deterministic and you should not be deterministic. If it is overfitting or underfitting, then it comes under deterministic. So you need to regularize the techniques. So this is one area that you need to focus. So there is something called entropy monitoring. That means it helps identifying or poor explanation. So that is nothing but entropy monitoring that you need to focus. So uh, these are certain areas that I could remember instantly, but other than this, there are so many areas that you need to focus. how an LLM model works. And
Okay.
these are very, if you have sound knowledge in these areas, then you are highly respectable in the Gen AI portion, and definitely companies will look forward for such a person who can build LLMs in such concepts.
How about application development or enterprise companies, not the product oriented or model based companies? So what do they
Yeah.
look for?
So correct. So now every enterprise has an access to APIs, right? So there is no
Yes.
doubt at all. Every API has its own capacity, capabilities to perform. Now,
Right.
whatever the API that you are choosing, and you need to understand how to utilize that. For example, every enterprise is facing a problem with sensitive information, sending it to LLM. Now, if
Right.
you focus on providing a framework that will have a better redaction logic before you call an API, and if that redaction logic works for your enterprise, then you play a vital role there, right? So one area that you need to focus is something sensitive information, sending it to LLM.
I
And
think
the
that will
other
be
area
most of the
is
use
model
cases.
performance. Yeah. Sorry,
Please
Anil.
go ahead.
Most of the use
Please go.
cases.
Please go ahead. I was saying majority of the enterprises obviously are compliance bound, and also they value their data, and they guard it, right?
Mm-hmm.
Which means redaction
Correct.
or doing redaction is extremely important and more common. I think that is important skill, I guess. That's what I was just saying, what you were mentioning. Every company,
Uh-huh.
they don't have their own
Mm-hmm.
LLM model, right? Obviously, they have to rely on open APIs, open AIs or Anthropics or Gemini's or Google's models, which are
Mm-hmm.
in their own data centers, right? Google data center is running their model and they're exposing the APIs via cloud, right? So enterprises,
Mm-hmm.
they won't be able to, if they want to use any of these LLMs,
Mm-hmm.
which means they have to send their private data, customer data, which means it's privacy concerns. And I'm saying all the use cases will be this protecting this part, like redacting part. I think that's more skill, I guess. That the skill is
Yeah,
needed
yeah,
there. Please go ahead. You're talking
yeah,
about model
yeah.
performance also, which is important. Sorry.
Correct. So redaction logic is very, very important because you don't want to send sensitive information, and that will not come under your policies, right? So you can't use something which is personal information data sending to external service providers. So that's one area that you need to focus. And the other area is coming onto the model performance. So every use case has its own performance metrics. You can't say that this API is will fit for all the use cases. You cannot tell like that. Your pipeline might change. Your responses, expected responses might change. And if your expected response is changing, your metrics is change, then you need to make sure your metrics is pretty much aligned as per the use case and as per the user need. So if you are talking about performance metrics, the main important role here is a developer can be a tester who understand the LLM response very properly than a user. So when you're developing an application, look in a user perspective, not the developer perspective. Do not technically understand how it is responding, but look at a user intent, how user look at the response. So look it in the direction and try to write a validation logic and try to bring a confidence score that I was talking about as per the user need. So every request should be a new request, not to sync with each other, and try to get a confidence score. And based on the confidence score, improve the performance of your model by either improving the prompt or providing a bit better context or refining the prompt or refining the context. So you can have several techniques, several other where you need to focus based on the confidence score or reason behind the score. So try to do that. That way you will. You can also have an additional LLM call saying that my human feedback says this response. This is his expected response, but you are providing some different response, and that's where your confidence you are saying around 60%. And try to compare version A, version B, version C, and group them all together, and that way you get a better response over the period of time. And do not think that over the period of time, if you have more data, if you have more training data, something, do not think in a way how ML model works or DL model works, because when it comes to LLMs, it is purely non-deterministic, and it can hallucinate, it can have more latencies. If you look at GPT-5, GPT-5 has temperature one parameter. That means it's a reasoning model. And where you, if you're comparing with GPT-4 or GPT-401, you have temperature parameter where you can bring down the hallucination. But now GPT-5 doesn't have that kind of parameter. So there is something called verbosity, or reasoning effort, something few other parameters it has. So as the parameters getting changed, then you can't rely on the same prompt, right? So you have to think in a way how to improve the performance, just understanding by writing a regression testing or something like that, not as a developer, understand it as a user, then you will improve the model performance in a better way. That is one suggestion that I could give. And if something that if I have to talk about related to validation framework. Okay, so every validation framework, they might go with open source frameworks, or you might have some other performance metrics. It's a huge area when you're working with LLMs, especially as a backend developer or an architect. It's very simple. At a high level, you say, I create a agent, and agent will go and perform. Okay. And he will give a output result. That agent will give a output result. It is very easy to say, but is how correctly it is giving a output result is very difficult to validate, because every response is a new response. Now this is called as inconsistency. So you need to make it very consistent. How you make it consistent? You by comparing the previous response with the current response, or previous set of responses with the current response. That is how you manage the state. That's where land graph came into the picture. And once land graph is into the picture, then you are managing the state in the memory. Now, every use case may not come into that picture, that you need to additionally focus on prompt versionings or prompt responses. Every use case may not fit there, but it is good to have to maintain that consistent response, aligning from one response to the another response, not to get diverge or not to get deviated, because every API call is a new call. You're not maintaining the same session like how ChatGPT maintains when you're opening a chat window. Your use case is not like that, and you're when you're developing, you're calling a LLM call with an API. So it's totally different. So you need to think in a different way how to maintain the states correctly. And not
Is there a
every use
standard for
case
that?
you have to go with. Yeah. Sorry.
Sorry, sorry to stop. Is there a
No, no,
standard,
no.
like you
That's okay.
said, as a
Mm-hmm.
developer? I think
Mm-hmm.
because it's new and evolving, I don't see a
Uh-huh.
structure yet, like architect, developer, tester, or something like that. Because we are focusing on all these in one place. As a developer, you have to think of the cost or GPUs or selecting a model or techniques for optimization,
Mm-hmm.
validation frameworks, as well as scalability, if it is scalable or not. So who decides? And
Mm-hmm.
is there a framework, like you said, for versioning or uh, versioning of the prompts, right? So is there a
Mm-hmm.
generic framework for building an application or enterprise application? What need to be
Um,
done? Are there any things like that?
So, for example, I ideally say that it's developer logic only in place. So, for example, now architect come and design the architecture, but architecture doesn't know that how internally it works unless and until a developer shares the information. So, developer has a complete knowledge on how the application works, especially when it comes to a backend developer who is working on LLMs. Now, he has to understand which logic should be in place so that your responses are aligned correctly. So there are a couple of logics that I have cracked with the user responses in my past experience. Okay, so one of them is I used to save into the database, and then I used to follow a technique logic in place so that it is correctly aligned. So that is the overnight thought that came into my mind. It's like been thinking how to solve this solution, and I put that logic in place, and it solved for 80% of the users. Now, will it works if I save something into the database? Will it works for every use case? No, it won't work. Now, there is another use case where I can't save the information to the database because there is no database present for that. It's a straight LLM call. Now, then what you have to do? Then you have to have an additional catchy database, Redis database present in your pods, which can spin instantly. Then, then what information I need to save there? What is the session ID that I am maintaining there? So that's another logic that in place to crack something. Then similarly, use case to use case, it purely depends on how developer is thinking there. So we cannot come up with a general thought, but something if you are feeling that application is having some bottlenecks and all, then you continuously think, especially a person like me, continuously thinks on the problem, how can I solve that problem? So when you continuously think as a user perspective, then you will be able to put some logic in place and you solve that problem.
Okay, let me put it this way then. A medium-sized application with
Mhm.
multi-agentic framework will need
Mhm.
a memory like a Redis for temporary memory and a database for permanent memory and a versioning for prompts and performance
Yeah.
modeling or a validation model all need to be there in place. Am I right?
Okay. Yeah, I'll tell you
Medium to
something.
large. Okay.
Yeah, I'll tell you something. When you say multi-agent, okay, so you have agent one, agent two, agent three, right? So agent one is nothing but it's an LLM call and you are getting a response, right?
Right.
Is it a true statement?
Yes. No, no. Okay, let me make it clear. So when I say multi-agent, I'm thinking of simulating what Claude has, right? So a master agent which actually reasons and asks the worker agents to do the actual work, something like that.
Yeah, okay,
Does
that's
it make
that's
sense?
also fine. Yeah,
Okay.
anything is nothing but for example, this is agent B, okay, agent C, okay, and agent one is a master agent. Okay. Now you are getting a response, and you got created this agency and agent B tasks. Okay. Now these are the tasks. Okay. Tasks for C and B. Let's assume like this. Okay. Now, how did you generate this?
Agent one will do that,
How did
right?
you generate? Sorry.
With a prompt. With a prompt to the agent
Uh,
one.
Correct. Okay. Now, how do you validate this? These tasks are correct.
Okay. Either manual intervention or
Yeah.
LLM as a judge.
Okay. Okay. Manual or LLM as a judge.
Right.
Okay. Now you got tasks C and B. Now you are sharing the task to C and you're sharing the same task to, sorry. So, so you're sharing the task to C and you're sharing the task to B, its own tasks. Now, now LLM as a judge told you something and it got generated these two tasks. And how you're relying on LLM as a judge or manual? if you're relying on LLM as a judge, you have another set of call for LLM
Yes.
and another call.
I think at least at one point, there should be an human intervention to test or
Yeah,
ensure
correct,
output is valid, right?
correct. So now you're calling another another call here. Okay. Then you have manual intervention also. Now, though you have another call to conclude something, but you're still validating here, okay, for agent one as a master agent. Now, C is shared this task, okay. Now, similarly, you follow the same technique, right? Here also, you follow the same technique. You say that LLM as a judge and you do manual intervention for task C. And similarly, you do the same for task B, right? So
Yes.
ideally, you're not you are not relying on anything. You are any which way you are trying to do some manual validation. You are not coming to conclusion on its own. But at any point of time, are you stopping these worker nodes? Are you stopping this agent? You are stopping this agent. You are stopping. You're not stopping, right? Now this request has come from one user. Let us assume. Okay, your request is coming from user one. Now you have 100 users. Okay. Now, were you able to manually scale to validate at every each point?
Not
You should
possible.
rely on LLM as a judge only.
Yes.
So you think that,
No.
okay, whatever I'm validating, I will call another LLM call. You will tell you will do something. Okay. Then
Can they
you do another
can there
LLM call. But again, sorry.
Abhinav, can there be scenarios where the outputs
Uh-huh.
of the tasks are probably binary, either success or failure, which doesn't require a sophisticated LLM as a judge or any manual
No,
intervention? Could that
you
happen,
do
or
that.
like, okay,
No, I'll tell you. You do that. My keyword is generating something that if, okay, if
yeah,
X happens, okay,
right, right,
say then you need to say yes. Okay. If
right,
not, no. This
right,
is my output. Yes or
right,
no. Okay.
right, right.
Then again you will go and verify whether is the X correctly happened or no.
The reason why I'm saying is, what if that task C is just making an API call, which is
Mm-hmm.
probably fronting a database. Let's say an enterprise has some data in the database and they have exposed a REST API. And in your AI
Mm-hmm.
agentic system, the task
Mm-hmm.
C is to go call the API, get the response back.
Mm-hmm.
It's a HTTP response.
Mm-hmm.
If the status code is
Mm-hmm.
200, which is successful,
Mm-hmm.
and probably I won't have to drill down further, because if it is 200, I'll get a JSON response
Mm.
as per the REST API.
No,
Uh,
for that you need to simply expose an API. That's fine, right? Why you need an agent for that?
uh, because this is an agentic system, agents are calling
No, no,
on
no.
behalf.
See,
Oh,
that's what I want to come to a conclusion. You
okay.
naming it as agent doesn't mean that it's an agent, right? So I observed this from many developers. They say retrieval agent. Okay.
Mm.
Retrieval agent. What do you mean by retrieval agent? Agent is someone who takes a decision on behalf of a human sitting there. Is known as an agent, right? It has to take its own decision. For example, the same REST API call that you are talking about, if my agent is taking a decision to call which API, then I say that it's an agent. But if it is a single API call, then I don't call it an agent. I just call it as a REST API.
Okay, this is a very good challenging point you brought up. Maybe
Yeah.
I'll further clarify. Let's say the system is, the user itself is like, probably it's e-commerce system. He probably placed an order.
Mm-hmm.
He is
Mm-hmm.
interacting with a chatbot, and he's
Mm-hmm.
asking a question, hey, what happened to the order I placed, right? So when it comes to
Mm-hmm.
the agent, which is probably order status agent, based on the
Mm-hmm.
customer's prompt, he identifies the intent. And when he calls the API, then he has to call the query API, not the update order or delete order. He's going to find out get order API, right? He's going to call the get order API, agent C. He's making the decision of call. So what the agent's intelligence there is, okay, he found out the customer's intent is he wants to find out the order status. So I'll be calling the order state, the find by order API instead of update the order or delete order. So not a pure API call. So agent is involved. Agent is making a smart decision based on the prompt, and he called an API. So when agent C gets an input, he has four possibilities: either to find the order ID, or update the order ID, or delete the order ID. Now agent is figuring out based on the customer's intent, and he's choosing. So he's making some intelligent decision. It's not pure API call, right? But then once he makes a call, because it's a REST API, the output of the REST API is either 200 success or it's failure. It's like 400 or 500 error. So that's where I thought, okay, if it is 200, so it is like a binary. So which means it doesn't have to be an LLM judge. That's what I thought. Okay, please go ahead. Sorry. I hope Ram, I didn't derail this, your original question. So.
No,
Fine, that's fine. I am learning still.
Go ahead, Ram. You're saying something.
No, I said it's fine. Anything is learning. That's fine. Go ahead.
Yeah.
Go ahead.
So the thing,
Amit.
what I want to say here is, so agents, so simple query generating, if you are generating 100 queries, okay, identifying the intent, okay, 100 times you're identifying the intent and 100 times you're generating the query. So do you think the success ratio of 100 times would be correct always?
Not necessarily.
Not necessarily. So it
10%
could be
failure.
some 70% success ratio and 30% failure rate. Okay.
Yes.
Now, what if the intent is not currently identified? So the success ratio is 60% of identifying and 40% failure. Let us think like this, because this is a real-time scenario, right? You can't 100 times keep static. No, what I'm saying is now agency got a task to identify the intent and call the LLM to generate the query. And as per your required, it is going to call the required table because you are generating the query and that is showing the status, and the status is says that order placed and success. Okay. Now it's an ideal situation where intent is perfectly identified, query is correctly generated and calling the right table by passing the payload. Now, if any point of time this is failing, this 40% and this 30%, then what are you doing? And how are you saying this is 60% success, 70% success? Then definitely, if your calls are depending correctly on this agency, then you need someone to validate that.
Yeah, I think the
You
intent
can't
vetting.
break the system.
Yeah,
Sorry?
the intent part will require an LLM as a judge. That's clear, right? Because when it parses the customer's prompt, like you said, it might in real world might not be 100%. It might have some issues, and it might probably guess 60% of the time, 40% it is errors. Then it'll mess up the rest of the flow, right? Because if his intent was to find the order and it is try.
100% correct. Then I will tell that master node, if it is not giving a proper task to agency, and if master node is not giving a proper task to agent B, then that would be the root problem, right?
Okay.
So what I'm saying is you can't rely on LLM for 100% success. So definitely your logic. Now, this is a real-time scenario. Now you will think that, okay, there is 30%, 40% failure for intent classification. Then what should I additionally provide for agency so that this percentage get increased? Then I will also come back and think, okay, so this master node, the master node is worked by Ram. Let us think. Okay, no agent one is the architecture was designed by Ram. Then as a developer, Anil is working and I am working on the database. Let us think like this. Okay.
Okay.
Now Ram says that no, I want several agents
to work on this. Then I say that no, Ram, this will be a problem because the agency is not calling a right database. I come back and tell to Anil. Then Anil says that no, actually agent A, agent B, and agent C is not identifying or getting a proper task from master node. Do you really require this master node? Why can't we identify from user intent itself to agency and agency? Let's remove this master node. You say something like that. Now the logic got completely changed in within a small discussion itself. Then to maintain this architecture correctly, then as a developer, we have to come up with an additional logic or some rule logic or some logic to break this problem or to improve the accuracy in a better way. Then how could we do? So now if you consider this as a real time, after several iterations or several testing scenarios, after observing with multiple regression testing user behavior for these 100 users, okay, then you write a reason behind that. Okay, for each call, as I discussed, okay, you write a reason behind why it is doing that. Then you come up by improving the instructions in the agent one, you improve the instructions in agent two, and improve the instructions in agent C, agent B and C, and see if it is if we are able to achieve. But that is specific to this scenario only again, and you can't come up with a general solution that can be implemented the same scenario with other one. So the thought could be the same, but scenarios would be different again. So what I mean to say is there is no standard methodology or something that could solve when it comes to LLMs. So we need to think very wisely how it could solve as per the use case. So that's what I want to explain.
That's too good. Very, very helpful. Thank you so much. And
Yeah,
one last
thank you.
question. I'll leave you with this. A simple question. So
Uh-huh.
when you use vibe coding, I try to use and build an application. I'm doing it right now. Every time I
Mhm.
build one, I use Cloud Code. It builds. When I hit a
Mhm.
problem,
Mhm.
it's messy again to go fix it because
Yeah.
I don't know what exactly, and if it does everything in one shot, it's hard to fix it. So I ask you to build it again. So what is the best way
Mhm.
to do it?
So, yeah. So your problem should not be like in a general way. You take a screenshot and fix this. If you say like that, it cannot understand. Okay. So give the instructions by mapping it correctly. For example, your problem lies in one folder. Okay. First, you identify, talk to ChatGPT or provide that information to any other chat model and say that here is a problem and I want to fix this problem using Cloud Code. You say something like that. Then it gives some set of instructions. Then you verify that set of instructions correctly, navigate to the folder and which area you need to change. Make sure you are giving that part correctly and provide the instructions of that area, what to solve correctly. Then it will go and identify the root problem correctly. If you dynamically give it, it won't identify. It will deviate completely.
Fixing it, but I'm getting other problems.
Yeah, I
So,
observed that. It when new instructions, new thought, and it will for first prompt you satisfy 100%, then you will deviate always in the vibe coding.
right.
So that's a hard part. I face the same challenges what you are facing. But
Okay.
I give minimal instructions only. My changes are not complete. For example, I see several problems. Then I come by fixing one problem at once only. That is what harness of engineering. Recently, you must have seen that kind of technique and the buzzword coming across in the YouTube channels also.
Yeah.
So make sure you're splitting the problems very minimal, not complete, very minimal.
Yes.
And
So
after
I split.
finishing the task, uh-huh,
Sorry.
yeah,
So,
go ahead.
like you said, I split the UI part separately. backend separately, and then testing part separate. So I split it and started building one at a time. So is it a good
Okay.
approach?
Yeah, it is only the good approach. It is the good
Okay.
approach. And identify the another thing. You have 10 problems, and somewhere problem 1 will be interrelated to problem 10. Okay. So try to identify and prioritize which problem comes first.
Okay.
If
Okay.
not,
Yeah.
you will go and do rework again.
Yes. Mhm.
If
Right.
if problem 10 is depend on problem 1 and problem 1 got fixed, and when you're changing or working on problem 10, then that will indirectly change problem 1, then you will come from root. So make
Oh,
sure
yes.
you prioritize the problems and then work according to the problem.
Yeah. Sure. Sure. Thanks a lot.
Yeah, so
Thank
think
you so
like
much.
this in any sprint planning, or when you are assigning a task to any user story or something. Think like this: first, you build all your features, then have all your user stories and work as per the user story, and you fix one feature, something like that.
Yeah. That makes sense. Yes. Yeah.
Yeah,
Okay. Sure.
Thank you, Abhinav.
Sorry for taking so much of time, and thank you so much, Abhinav.
yeah, no worries. Thank you, and it was very good interaction with you guys. Thank you so much.
Have a nice day.
Yeah, you too.
Thank you,
Yeah,
Rao
thank you
garu,
so
for
much,
facilitating
Abhinav.
this.
Thank you all. Yeah, thank you.
Yeah, I think we are good for today's session. So thank you so much, Abhinav, for and taking up the queries. And thank you all for attending today's class. So we'll keep you updated about the new batch and next updates. Thank you so much.